mTOR, mammalian target of rapamycin, is well known, very important protein kinase. The role of the protein kinases is to transfer phosphate from phosphate donating molecules to the specific substrate in order to activate or deactivate the reaction. So it is called phosphorylation, by the way. So let me show how phosphorylation works really quick, very simple. So let's say this is our phosphate donating protein, okay? This is our phosphate donating protein, and let's say this is our specific substrate that gets phosphorylated. So we have ATP here, 3-phosphate with adenine, okay? So an adenine diphosphate and adenine with 2-phosphate. So we get a free phosphate from here, and we add that phosphate right here. So as you see, the protein or specific substrate got phosphorylated. So this is called phosphorylation. Phosphorylation. Simple as that. So what is the opposite of phosphorylation? Not hard to guess, right? It is dephosphorylation. Dephosphorylation. So what do we do here? We're losing phosphate. We're losing phosphate here. So that's how it goes, okay? So that's how the phosphorylation reaction goes. So when we look at up here, we see some of the functions of mTOR. So it negatively regulates autophagy, and autophagy is known as a main degradative process within cell. So it negatively regulates a main degradative process, and that is certainly good. And cell growth, cell proliferation, protein synthesis, and transcription. But I'll specifically talk about protein synthesis, what's going on when we do resistance exercise, and what are the most effective ways to be able to increase our protein synthesis. So that's what we're trying to answer. So over the past decades, there has been a lot of research related to mTOR and protein kinase, protein synthesis. And most of the researchers have shown that the most important regulator of protein synthesis is mTOR. So why mTOR is important? But before that, let me explain a little bit about what's going on here. So let's say here we have stimulant, okay? Stimulant comes and binds receptor, and that activates the adapter, and as a result, PI3 kinase and AKT are gonna get activated. And AKT is also known as a protein kinase B, okay? It is also well-known protein kinase, by the way. And AKT will inhibit TSC1/2. Don't be so obsessed on the name of the molecules, but I would suggest you at least know this molecule because it is inhibitor of mTOR. So that means whenever TSC1/2 is activated, mTOR will be deactivated. So we certainly don't want that when we do resistance exercise. So AKT comes here and inhibits TSC1/2, again the inhibitor of mTOR. So what happens if we inhibit the inhibitor of mTOR? That means mTOR is activated, right? So as a result, we're gonna see cell growth, the activation of cell growth. But when we inject rapamycin, inhibitor of mTOR, we see the reaction of mTOR is reduced by 70%, and that is absolutely significant amount of inhibition. So what happens if we inhibit mTOR? That means we also inhibit cell growth. So that's why it is really important to know the factors that either turn on or turn off mTOR in order to optimize the protein synthesis, in order to optimize the results of strength training.